Hello everyone and welcome to this video about t-tests. T-tests are an essential tool in statistics which are used in majority of introductory courses on this subject. When to use a t-test? T-tests are used to compare the means of two groups, so not three, only two groups. So we want to compare these two groups and determine if there is a significant difference between them. So for example, we might be looking for a significant difference between weight in men and females, or for instance different GPAs among students of business and students of psychology. And if we have only these two groups, then we will use a t-test. And in these particular cases that I just mentioned, we will use a between subject t-test. Between subjects t-tests are used when we want to compare the mean of two different groups, but they are independent, meaning that it's male and females, business students and statistics students, or business students and psychology students. It is not the same group measured twice. So we have one measurement and we have two groups. So we have the DV, the dependent variable, which is going to be a score, whereas the independent variable or the between group variable is going to be a nominal variable or categorical variable. In this example we have here in Jamovi, we have a score on self-esteem and gender, male and females. And we want to see whether there is a significant difference between the two. So in order to do this, we must go into t-tests, independent sample t-tests, in as much as independent sample t-test for Jamovi represents the between subjects t-test. So we click on independent sample t-test, we will put gender in the grouping variable and self-esteem in the dependent variable. Then we will check some more of these boxes. We will want to see the normality and homogeneity, and we will want to see mean difference, effect size, and descriptives, and this depending on the assumptions. So first of all, let's check our assumptions. We have the Levin's homoscedasticity, which is not violated in as much as it's more than 0.05, and Shapiro-Wilk, it's also fine in as it's 0.38, so that's definitely more than 0.05. So we know that our assumptions are met, and hence we can proceed with the student's t-test. In case our assumptions were not met, then we'll have to do something different. In case of not having homogeneity, we must perform a Welch's test. Whereas in case of not having normality, we will have to do a Mann-Whitney U-test. But again, the procedures will be the same, they will just have some minor differences which I will discuss a bit later in the end of the video. So, once we are certain that our assumptions were met, we must check our actual results. Our p-value here is not below 0.05, meaning that our results are not significant. And hence we will remove the effect size, which as you can see here, it's 0.134, but we don't need it in as much as if our results are not significant, it could be completely due to chance, and hence we don't want to report it at all. This being said, we can still look at the descriptives. We see that the mean of males in self-esteem is 60.3, whereas females is 59.7, and obviously this mean difference of 0.536, it's very unlikely to be significant. It measures such a small difference. And hence, we must refuse the hypothesis that there will be a significant difference between male and females on self-esteem. And finally, we have the special instances of t-tests that I was mentioning before, of the between subjects or independent samples t-test. Now, the procedure which we will have to follow is virtually the same, but if you remember, as I mentioned before, in case we do not have homogeneity of variances tested by the Levin test for homoscedasticity, in this case we should perform a Welch's test. It works exactly the same way as the student's t, so you will always have a p-value, you will always have an effect size. It's just more adjusted for unequal variances, but it works exactly the same. Whereas if our data is not parametric, so if we do not have a normality, meaning that the assumptions of Shapiro-Wilk has been violated, then we will have to use a Mann-Whitney U-test. Mann-Whitney U-test is again basically the same as a t-test when it comes for U and data interpretation. It is not when it comes to calculations, in as much as students T is using and comparing means, whereas the Mann-Whitney, being the data non-parametric, is comparing medians. But otherwise, the interpretation, especially for your introductory courses in statistics, would be the same. So in summary, t-tests are an important statistical tool used to compare the means of two groups. They are mostly used, to be really honest, in introductory courses, in as much as in the real-world research you would rather use other tests like ANOVAs, which can handle more levels, in as much as t-tests are a bit more basic. But of course, if you are testing, for instance, drug versus no drug and you're doing some clinical trial, you can still use a t-test, right? So they are still like an important bedrock which will build your knowledge and better your knowledge of statistics when you will reach the point of doing ANOVAs. But they're still very essential, but also quite easy. And hopefully, by following the steps outlined in this video, you can confidently perform t-tests as well and interpret the result by yourself for both independent sample and paired sample t-tests, and also for their variations like the Mann-Whitney U-test and the Welch's t-test. Thank you for watching.